Today we have Andy Rayner from Nevion speaking about a case study, and I think these are some of the most interesting presentations that we have because they give us a feeling for what it's like to actually build these systems and make them work. So Andy's going to be talking with us about PlazaMedia, which is a all IP facility that was built recently in Germany, and I'm sure we'll get a lot of good insight. So Andy, take it away.
Thank you very much. Good afternoon. I can't believe we're in afternoon already on day one. Hey, and we're still going. Very good. So a little bit about me. My name's Andy. In case you haven't guessed from the accent, I'm from the UK. I spent 22 years working for British Telecom, which is the telecoms heading up their broadcast technology centre. And then I joined Nevion. I went to the dark side of Vendorland about 8 years ago. And I put this on here because in case any of you guys are actually doing the run tomorrow morning, this was a picture I took last year when I did the 4K run. So I think I was the last person in the run. And this is a classic BBC test card, which when I left BT, they did my hair up and put me on the picture. Anyway, a little bit of amusement to get started with. What I want to do is just run through a few different elements from our perspective as a vendor and partner as supplying our technology into the PlazaMedia opportunity. So a little bit about PlazaMedia first. I don't know if anyone of you were here at our event yesterday. Jürgen Conrad, who oversaw a lot of the technology deployment here, gave a presentation on this. This is kind of a summary of some of the things that he was saying. A large broadcaster facility provider in Germany, and we were very excited to work in partnership with them to provide this. So this was a very fast deployment. I think time to market has been something that we've been very proud of. These guys built and deployed this during 2018. And I think one of the most exciting things from our perspective in terms of this was they actually sat down and did if you like, a top-down analysis of the flexibility they wanted in the facility. So we didn't start by talking about like the nuts and bolts of what switches we wanted to use or how we were going to do stuff. It was they actually sat back and said, what do we want to achieve? How do we want this facility to work? What do we want the flexibility to be within the facility in terms of flexible rooms, dynamic control, dynamic sharing of resources? So all of those requirements of the top level came in and the design was done off the back of that. And that's actually, I think, a very good way to approach this in terms of actually making sure we go from the requirements first, think about what's best, and then come in with the technology to provide the solution. So a quote here about from the chairman about the solution and what the aim was to do at that point. So a quick overview of the solution as a headline level. First of all, they have a production network and a playout network, and one of the requirements was, from a resilience perspective, was to actually make sure that the architected network here was resilient from here. So in the event that there was any large issues or large failure issues, that the two had autonomy and could continue to working, even though they were a fully synergistic, linked together IP solution. I think this picture probably reflects best the kind of the flexibility of the architecture. What I was saying a couple of minutes ago about the solution is, this cloud was blank, if you like, apart from the fact they had a vision for it to be all IP, but what was in there was blank. This was the requirement, was multifunction rooms that can actually make use of the equipment resources that are available in a dynamic way. And I know that when we've actually been around the facility ourselves, they've actually demonstrated that you can actually pack up in one room, go to another room and carry on, because you can dynamically switch everything together. So this was the ultimate flexibility requirement that we had as we started working with this customer on the design. So here's a few key stats. It's always good to have a few vital statistics on what's happened in here. I think probably one of the key ones here is these 17 different SDI routers that they had, all with tie lines between them. So actually doing any changes actually was a very complex process. And the other facts here are just kind of, if you like, figures on some of the other numbers of the connectivity that we ended up working with here. So in terms of benefits here, at the end of the day, it's all about doing more for less and actually having a lower cost base. It's not just about putting IP in because IP is cool. You only want to do that if you can leverage benefit. And just on that last picture, the benefit, one of the key benefits, as we saw it as a supplier into this to the customer, was actually being able to use that dynamic sharing of resources and dynamic sharing of the facilities. Obviously, cost reduction is a key thing, and I think although it's been discussed how much cost saving do we have with IP solutions, if you actually look at the total cost in terms of the cost savings and the flexibility, then these kind of solutions really are costing in now. So a little bit about the project from our perspective. We actually worked with our partner in Germany, who actually did a lot of the work on the ground in providing this, and we had some of our solution architects and teams coming in and making this work. So these are some of the sort of key headlines, again, analysing the project from our perspective. So we'd actually been doing some work with this organisation before, with this customer before, so that had been successful work. So that was something that was positive at the beginning of the project. We had video iPath doing fabric control. We had lots of flexibility in the architecture we chose to actually introduce pieces of equipment that necessarily weren't fully compliant in an IP NMOS type world. And one of the main ways we were able to do that was with the SDN architecture. The actual solution we deployed for this in terms of the switching and routing of signals was SDN based using OpenFlow. And one of the key benefits we were able to do within that architecture was to do address translation on the egress of each of the leaf flows into the end equipment, to the receiving equipments. And what this means is we're able to deploy very fast because we don't need to deploy detailed drivers for third-party equipment that doesn't need it. We're actually able to actually do static configurations of the equipment and dynamically change the network to actually route the signals to those pieces of equipment. So that's a key piece of flexibility which we've seen benefit from in many solutions, including this one. Obviously, as things like NMOS become more all-pervasive and the whole ecosystem is truly, the control layer, if you like, is truly aligned and everyone is following that, then some of these requirements for this kind of flexibility go out the window. But this is an immensely useful tool for supporting any pieces of equipment that are not compliant to NMOS. Optimum use of resources and bandwidth management. One of the key things that we've found very, very important, in fact, one of our kind of design principles in Nevion is being to do explicit routing of signals. So we don't rely on routing protocols in switch fabrics. We actually make sure that we traffic engineer and explicitly route all of the flows. And that means we can actually be very, very confident that we're not going to exceed bandwidth, and very confident also that we can do diverse routing properly and provide resilience. So lots of key reasons for doing this SDN explicit routing. And then obviously future-proofing. I mean, video iPath now fully supports NMOS, but obviously as devices gradually embrace NMOS, then there's the potential to actually future-proof and introduce things in a fully NMOS compliant manner. So as a supplier into this customer, we actually provided several different elements. And one of the things that we find is always very important in these solutions is actually providing knowledge on how to do things, if you like, best practice. And if you're free at any point during the show, we're in South Upper 5510, and we've actually got a whole load of things on best practice for IP facilities and IP networks in general, which we'd like to share. So that's been a key thing. Also talking about PTP, one of the key things that's very important. Some of you being aware that there's been discussions on the security of PTP and the risks to IP facility infrastructures to do that. And one of the key things that we've done in the way we've actually done the routing of the PTP means it's a very safe and secure way of distributing the timing information to through the system as well. And then all of the other classic parts of a project delivery phase. So timeline, this is very, very important. And we've heard several stories about IP deployments taking an crazy long time. We've recently done another one in Iceland that we delivered in 6 weeks. So 6 weeks from receiving order to actually a full deployment. We had discussions and pilots with this customer, but the actual order was placed in April and it was on air in August. So this stuff doesn't need to take a long time, is the key message. It is possible to deliver these IP facility infrastructures in a nice compact time delivery frame, and that actually really helps customers to meet their requirements. Another quote here, that this actually went very well from the customer's perspective. So in terms of architecture, we can, again, if you want to come, we can talk about best practice. This is one of the demonstrations we've got on one of the tutorials we've got on our stand, but we used a true leaf spine architecture where all of the leaves are honed into the different spine switches to give a fully resilient architecture there. In terms of how the stack worked from a control perspective, this is how things work. So this customer was already using VSM as a well-known control layer, control surface. So they stuck with that. Video iPath as the kind of intelligent engine that's doing all of the orchestration and routing is integrated using the Ember Plus control protocol. So that sits underneath and doing all the orchestration elements underneath VSM. Then we had Virtuoso, which is providing all of the gateway functions. Also, other companies were providing other gateways as well as part of the infrastructure. And then we provided a couple of different makes of switch fabric that were specifically used for this. The spine switch was Mellanox, and eMerge was used as the leaf switches. So here's a kind of quick summary of the different things that were involved. So video iPath is the orchestration with the control surface being VSM. Lots of adaptation from Virtuoso and audio processing as well. And then various other pieces of equipment from other vendors which we fully integrated to actually make this work. And then here is the control stuff. And then we also had both Tektronix and Meinberg PTP references within the solution as well. So this is kind of a top-level view, a very simplified view of the production and the play-out environments as part of this. By the way, if you're interested, the presentations or the slides will be available, I think, online as part of from the IP showcase after the show. But basically, standalone orchestration, SDN orchestration control that's resilient, that's able to, should there be any issues with the production environment, still take all of the live feeds and come through. So, and each of these, so this iPath SDN orchestration system here is actually in itself resilient, running on hot standby architecture servers. So this is the kind of a simplified diagram of the solution. And then just to give you a little idea of the kind of way all of those bits came together in terms of routing, so we can see the open flow control of both the leaf and spine fabrics, other pieces of equipment there, and then the VSM control at the top, and then video iPath doing the orchestration of all of the signal flows for the PTP, the audio and the video. So this is the key uses of the facility, and went on air, as we said, in August last year. The multifunctional room, this diagram possibly doesn't show it that well, but one of the key requirements, as I said from the very beginning, with the vision this customer had of the flexibility that was needed, was actually having many rooms that could be repurposed. And I think probably before several of you arrived, one of the things that my colleagues have been talking about is when they're visited, you can actually quit doing a production in one room, actually press a button and carry on another room, because all of the resources from the equipment can be actually rerouted automatically to whichever facility you want to use. So different size rooms, and you can do different things at different times in different rooms. So a very flexible architecture. And this gives you some pictures of some of the different rooms from the place, from the environment, the small commentary rooms, and then different size multifunctional rooms. And again, some positive input from the customer. So, in very quick summary, so this was a requirement to move to a very flexible, assignable, multifunction capable environment, leveraging IP to provide that full level of flexibility. This was the solution which was deployed, and again, one of the key things from our perspective was the kind of time, the delivery time which we managed to achieve on this, which I think helps go to prove that this technology is usable and is deployable in short time frame, and the benefits are outlined here. So hopefully that gives you a good view. We'd like to talk to you about any other elements of the technology that underlines this. We've got many use cases from other deployments that we've done in recent times, and we'd like to share with you our view on the capability of the technology. So South Upper 5510, and because I don't often get very many good cups of tea here while I'm in the US, I'd like to think, I think we do probably the best cups of tea at NAB. So if you'd like to come and join us for a cup of tea, we'd love to share some of the tech and some of the best practices which we've evolved, not only for this solution, but for lots of others that we've deployed over the last couple of years. So thank you very much for your time. Hopefully that's been informative, and as I say, do come and have a chat, and either now briefly or come over for a cup of tea later. Thank you very much.
So Andy, we have time for a couple of questions.
Okay.
If you're willing to
Yes. Very good.
host them. I guess one of the things that I was curious about is what kinds of provisions have you made deliberately to allow for unforeseen things in the future? You know, new technologies or new applications. What about the expandability of what you've done?
Okay, so I think a couple of things. First of all, the leaf spine architecture of the switches means that there's actually quite a lot of flexibility for expanding the capacity there. I think the other thing is that I use an expression: our hardware is soft. But what I mean by that is, all of the elements that we provide are software-based, both the orchestration and control layer, but also any of the adaption and processing pieces of equipment. And that means actually we're very, very easily able to support future standards. So for instance, actually, Video iPath, at the point we introduced this last year, wasn't fully running NMOS. But now we have an upgrade which is fully supportive of NMOS. So that gives you an idea of some of those software integrations that have even happened in the meantime between last August and now.
And how much did the objectives of the project change during the course of it? Was there a single consistent plan that was followed all the way through, or did you have to dodge and weave a little bit?
Okay, I wasn't the solution architect directly involved, so I can't comment on that directly. But the timeline was something that we were very proud of in terms of delivery.
Right, you should be. Anybody else with any questions? Okay, go ahead. Hold on.
Yeah, I saw the SC2110-31 on the screen. Can you share anything more about what was the potential that would be used for? What type of streams? Okay, so
you mean in terms of the -30 streams or the -31? Okay. So the key difference between -30 and -31 is -30 is basically a transporting. It's designed for uncompressed PCM audio only, but it will actually carry transparently anything that's 24-bit 24-bit based, as long as there's no timing reconciliation that has to happen in the processing. Dash 31 is designed to actually carry all 32 bits of what you would know of as the traditional AES-3 frame. So that carries all your CUV, P bits as well, and your, which means that any kind of compressed, any kind of compressed or anything in audio that makes use of any of those other bits is able to go transparently through the system. So that's the difference between Dash 30 and Dash 31. Things like Dolby E should actually be able to theoretically carry as 24-bit within a Dash 30, but the differentiation is the Dash 31 is all 32 bits carried transparently, and the prerequisite of Dash 31 is also that you don't do things like sample rate conversion, because obviously that completely destroys the transport, whereas theoretically, if you're doing timing domain reconciliation, especially if you're going between campuses, you may want to do sample rate conversion on a Dash 30 stream, but you wouldn't want to do that on Dash 31. Does that answer your question or your comment or not? Yeah.
Okay, thank you, Andy.
Thank you, Bob. Thank you very much, everyone.